So what I'd like to do is introduce the environment. So you start out, you're looking at OSM and you go, I have an idea. There's something that I would like to see in OSM. So the good thing about OSM is that everything is developed in the open and everyone can contribute. There's no membership fee or anything like that required. It's not like you have to do anything in specific in order to be an OSM contributor. There are different ways we can contribute. There are features, and there's an actual feature, proposal process that we go through where you write up the feature, you describe it, and it's actually submitted as a code change because, well, it's text, and text is easily stored as a document in a source code control system. There's bug reports. You can report bugs against it. Not knowing how to change it or not knowing how to fix it shouldn't be a barrier to going ahead and saying, hey, I found something, this is what I did, this is what I think should have happened. So bug reports are welcome. There are service descriptors, such as the ones that you saw earlier this week. Being able to write a descriptor to be able to onboard a package is another way of being able to contribute. One of the things that we have is the VNF onboarding task force, and that is available for anybody to participate in. And if there's a particular VNF, or even if you work for a company that sells a VNF, we'd absolutely love to support you and work with you on creating a descriptor for that. There is the documentation, the user guide, which is our OSM Quick Start. So you can read the documentation, review it, submit comments, make changes, add improvements. That's all, source code controlled as well. And anybody can, sign up for an account and be able to make what we call merge requests in Git Lab and go ahead and help us improve the documentation. There is the testing guide. So not only is there the ability to modify the testing guide and improve upon the documentation, but you can also use that to run some tests of OSM, ad hoc testing, or help figure out how to improve on tests or have ideas. So yes, the test environment and the test documentation. You can actually browse through that and start executing some tests or improving that documentation, and you may be able to either contribute bugs or contribute code changes to the documentation, or even get ideas for new features. And of course, there is our automation test suite. We use the robot framework for our entire test suite, and once a day, every day, for our V8, V9, and master development branches, we run a suite of robot tests, some 280, 290 tests. If you happen to have a particular aptitude for robot, or if you're interested in that level of automation testing, this is also an area where you can participate. So there's many different places where you can jump in and participate and help us move OSM forward. So the overall landscape of the tools that we use. One of the main tools we use for source code is Gerrit. Gerrit is a code review system where I can make a change to source code in my local environment. And once I'm happy with that change, I can publish it to Gerrit to start a peer code review. And this is something that allows us to see what files were changed, what did the file look like before, what does it look like now, and it gives us the opportunity to hold a dialogue and be able to communicate about the change. If somebody is unsure or the module development lead is not quite sure what you're doing, they have an opportunity to ask questions. As well, you can post code and go, I don't really understand why this is happening. Can somebody explain? And so this is a dialogue tool in the form of code review. We also have Git Lab, which is where our, so Gerrit is used primarily for all of our core packages. So things that are actually part of an OSM release, and GitLab is used for ancillary projects, such as the packages, the documentation, and it's also a mirror of Gerrit. So while you will be able to see all of the core OSM source code in GitLab, it is a read-only mirror. Any real changes to the source code will always come through Gerrit. But GitLab is also used. It's got a nice web interface, and it's easier to just simply view source code and navigate it than Gerrit is, if all you're wanting to do is take a look at some source code, or be able to say, send a highlighted line of text to someone. You can actually, highlight a line of text in the source code view of Gerrit, and you can get a URL that you can send to somebody, go, here, look at line 57, and it'll take them right to that line. We use Bugzilla for our bug reporting tool. So it, at this point, does require an Etsy, like it requires a login in order to be able to see things, so you will need to register. And registration is something that Sylvia will be mentioning tomorrow during our How Do I Get Involved in OSM session. We also have Jenkins. If you're not familiar with Jenkins, Jenkins, as a little picture of a butler that goes along with it, is what performs all of our tasks for us. So when new code gets submitted to Gerrit, Jenkins is notified and a new job starts up to perform validation of that code change. It's also used, as I mentioned, we have these daily jobs that run this suite of robot tests. That's also Jenkins. So all of our code compilation, test automation, publication of artifacts to public repositories such as Docker Hub, Jenkins is responsible for all of that right now. And we have the wiki. MediaWiki is the tool that powers our wiki. We have both the public OSM wiki and what we call the, I don't know, Sylvia, what would you say the best name for that is? I wouldn't really call it the private wiki. The internal wiki, it just requires a username to log into.
The original name was the project wiki. It's where
project.
Yeah.
Okay, thank you. So there's the project wiki, and like other tools, it probably requires, actually it does require registration in order to be able to log into it. So what languages do we use in OSM? Python. The vast majority of our code is written in Python. It is a relatively simple language to learn. If you're not familiar with it, don't be intimidated. We're actually going to be seeing Python code this afternoon. We're going to be encouraging you to make modifications in Python code and be able to test that as well. So that is a primary language that we use. Our web UI is also written in Angular and JavaScript and runs using Node.js. So there's a lot of NPM modules installed. Anyone who is an Angular and JavaScript aficionado, there is an entire segment of OSM that is for you, all about the web UI, responsiveness, look and feel, all of that good sort of stuff. Oh, that reminds me, there's one other place that you can contribute: localization of OSM. The web UI is localizable, and it does have translations for other languages. I believe Spanish is fairly well translated right now, but if there's, if you're just interested in lightweight contribution and you happen to speak another language and you would like to see OSM web UI translated into your language, absolutely, you can do that, and that would be a wonderful thing, a wonderful way of getting involved. And lastly, Bash. We have a fair amount of Bash scripts. There are things that we do from certain things in the compilation process, the installer, etc. There are quite a number of things written in Bash. I realize here that perhaps I could argue that Docker, although not really a language, we do have Docker files that are maintained and managed in our system, as well as the CI/CD pipeline itself uses a scripted version of Java called Groovy. I neglected to put that one up here because I was thinking about primarily the source code of OSM. But now that I'm taking a step back and looking at the bigger picture, another way to contribute could be to take a look at the CI/CD pipeline in our build automation. If you happen to have particular experience there or are interested in that, that is another possibility. I happen to be the Devops MDL, so shame on me for overlooking that one. I certainly have more work that I could possibly do in a day at any time, and if anybody has a particular passion or idea for that, love to hear from you. So, what does OSM look like? How do we break this down? OSM is a series of microservices. What this means is that we have individual images or Docker images that are built based upon a certain set of modules, and these are, while coupled with each other through an API, they are somewhat independent and they run as standalone processes tied together through the Kafka message bus. So in our particular picture here at the top, we've got the OSM client, which is what you've been using from the command line to do things like OSM NS list or OSM and network slice create or launch, sorry, NSI create. So these are the things that you see from the OSM client. We also have the light UI. Actually, I just realized this should be renamed. We call it the next generation UI now. So originally our light UI was much more JavaScript, and it was rewritten from the ground up by our good friends at Tata to be based on Angular framework. So that is the next generation UI. And both of these things communicate through the northbound interface. So the northbound interface is another module, and it pulls in what's called the OSM Information Model. This information model is where Sol 6 is described. So everything that we do comes through this common information model, and then it gets translated and sent through the Kafka bus as messages for the other things to pick up. The lifecycle management component is responsible for the life cycle of network services. So it is what controls when a new virtual machine is launched, when a virtual machine needs to be destroyed, when a Kubernetes container needs to be created, when it needs to be destroyed. Inside of the LCM, as a component, is the N2VC, which is the VCA. Oh my goodness, I need more sleep. I'm drawing a blank. David, what does the VCA stand for again? Oh, perhaps he's not in the call. Oh no, there he is.
I can help.
Oh, sorry, I'm drawing a complete blank.
Sorry. Is network service to VNF communication.
Okay.
And basically it acts like the Juju client, okay? And the VCA is the Juju controller.
Right, but what specific? Oh, there it is. VNF configuration and abstraction. Thank you, Gia. I could not remember what VCA itself stood for, but this area here. So lifecycle management isn't just VM creation, deletion, container creation, deletion, but it's also, as David was saying, to go back to that earlier picture when we talked about OSM creating an execution environment for code to execute in, that is what the VCA manages. So anytime you have a primitive that needs to run, or any sort of configuration scripts that are running, all of these things happen inside of the this virtual environment, this execution environment that the VCA is responsible for. So the LCM says, well, I need a new VM and I need networks created between them, and I need this plumbing, and it will let the RO, or resource orchestrator, know about this. The RO is the one that has the plugins for all of our different virtual infrastructure managers. So RO takes a common instruction such as launch a virtual machine, and will translate that to the specific instructions to create a new instance, EC2 instance, in Amazon Web Services, or launch a VM in Nova under OpenStack, or create a virtual application in VCE. So whatever the analogous equivalent is inside of your virtual infrastructure manager, RO is the one that does the translation from I need a network service to here is how we actually instantiate that service. RO also has the plugins for the SDN controllers. So any SDN operations will be performed through the RO as well. We have some more modules over here. The placement module. So it also sits and listens to the Kafka bus. And when placement is active, as Lars described yesterday, saying, okay, there are specific places where things should be run based upon a set of rules. Placement will work in conjunction with the LCM and RO to figure out where the best place for that network service, for that virtual machine or whatever it is, to be launched. So it actually sits on the Kafka bus and listens to those messages. Paul is a very similar idea. it listens to the Kafka bus and it watches messages go back and forth. When it sees that there is a report from an alarm basically saying, oh, CPU usage has exceeded 80%, Paul will then put a message back on the Kafka bus asking LCM, please scale out this particular network service. So Paul is the one that's responsible for listening for alarms of CPU, network, etc., being high or low, and will instruct LCM what to do accordingly. Mon, which perhaps I should have described just before Paul, Mon is the one that monitors the OpenStack, the Amazon Web Services, I'm not sure if Mon monitors AWS, but it definitely monitors VCD and VMware VIO. So Mon does a lot of the monitoring of the infrastructure. It's the one that collects the statistics and puts the alarms on the bus for Paul to consume. So the Mon and Paul modules are quite related in that Paul is the consumer of messages from Mon. A little bit of a breakdown now of who's who in OSM. So we saw, I'm going to go back here. I mentioned, okay, well, there's this LCM, there's this information model, there's a northbound interface, there's these services. And a lot of these things have been broken down into what we call module development groups. And in the module development group, we have the technical steering committee, which is responsible for authorizing any changes to our information module and our northbound interface. Now, they obviously have more of a responsibility than just that. They're responsible ultimately for approving features, setting the technical direction for the project. They do convene weekly, bi-weekly by themselves, and on alternating weeks with the MDLs, where we conduct conversations and be able to make decisions and steer where we're going. The user interface has a particular lead who is Bharat. Resource orchestration is led by Eduardo. Lifecycle management is led by Fabian. Here's that information model and northbound interface that I mentioned. You can see that the chair of the technical steering committee is Jose Miguel. And so he is what we would consider the final authority on approving changes for the information model and northbound interface. Service assurance is led by Subhankar. And he is, so that encompasses Mon and Paul, as well as placement would come under this as well. There's been some interesting investigations, features, experiments coming out of service assurance when it comes to machine learning and possibilities for healing and closed loop automation. So if you happen to have a particular interest in closed loop automation, or even some of the machine learning aspects, or if you're doing any research papers or any research studies in that area, I'm sure he would love to hear from you. As I mentioned, Devops is where I come into the picture, and that is the end-to-end build process, verification, being able to run our automated tests, etc. And then the N2VC is David Garcia. Over here, we have a couple extra what we call task forces. I've mentioned this before, the VNF Onboarding Task Force, led by Gian Pietro from Whitestack, And this is a group that is ready and willing to assist anyone in writing descriptors, writing packages, being able to onboard any sort of service. We also have our marketing task force, which is led by Mona. And this task force is responsible for all of our communications, white papers, newsletters, mailing lists, etc. And going right back up to the top, we have a leadership group who is responsible for the ultimate direction and far-reaching goals of OSM, as well as our end-user advisory group, which is collecting feedback and representing the voice of the users and consumers of OSM, making sure that their voice is heard. With that, that is our overview and who's who of OSM. Is there anything from that you would like further clarification on, or were we good with that as an overview?